Hey everybody, today we have notes number 30, I think it is, and today's the day we start trigonometry. I'm always really excited to start trigonometry. It's a nice change of pace. We get to use some of the geometry that we learned before and build on it. So this is from Chapter 5, and what we end up doing to start this unit is doing part of Chapter 5 and part of Chapter 8 together. And then we end up going back and picking up 6 and 7. So we have a lot of trigonometry to do. It is a nice fresh start. You do need to know a few things from back in geometry, and we build on what we learned. So you really don't want to miss anything. From this point on, you don't want to get a week behind or 2 weeks behind or something, because everything builds on what we just did. So we're going to start out today with vocabulary, and you'll be familiar with a lot of this vocabulary. Some of it's new. And I would encourage you to read section 5.1 in your book and take a look at all the diagrams to help you understand the vocabulary. And after I go down the list of vocabulary, I'll work through some examples with you and draw some pictures. Okay, the starting ray of an angle is known as the initial side. The ending ray of an angle is known as the terminal side. I will illustrate these in just a minute. In trigonometry, the positive direction is considered counterclockwise. Counterclockwise is like this, going from right to left, you could say. But I suppose if you're on the bottom half of a circle, you're going from left to right. So not the direction that a clock would go, but the other way. Okay, here are some terms you learned in geometry. If you have an angle that measures between 0 degrees and 90 degrees, what do you call it? That's right, it's an acute angle. How about an angle that measures 90 degrees? What do we call that? You got that, you're right. It's a right angle. And an angle that measures between 90 degrees and 180 degrees? Absolutely, that's an obtuse angle. You got it. You remembered those very well. And then if you have an angle that measures exactly 180 degrees, you call it a straight angle. You get a straight line. In geometry, you didn't deal very much with angles beyond 180, and most of what you did was inside a triangle, and so your angles were usually less than 180, but you'll see as we go through this chapter that we're going to go beyond that, and we'll learn how to use trigonometry for bigger angles. Okay, here are a couple of other terms you learned in geometry. Complementary angles are two angles whose measures add to 90 degrees. We would say that the angles are complements of each other. And supplementary angles are two angles whose measures add to 180 degrees. So we would say the angles are supplements of each other. Now, if you've ever had trouble remembering which is complementary 90 or is complementary 180 or which one goes with which one, I'll tell you my secret to remembering. So for me, I remember that C comes before S in the alphabet. So alphabetically, C is before S. And 90 comes before 180 numerically. So C before S, 90 before 180, C goes with 90, S goes with 180. Okay, the next thing you may have never heard of before. These are ways to break down a degree. So we know there are 360 degrees in a circle. That's based on probably a Babylonian calendar from way back when. But you can break a degree into 60 equal parts, and each of those parts are called minutes. There are 60 minutes in a degree. It's like having 60 minutes in an hour. You can also break a minute down into 60 equal parts called, can you guess? 60 equal parts to make up a minute? Yep, they're called seconds. There are 60 seconds in a minute, and therefore, there would be 3,600 seconds in a degree. Now, I typically don't break down my degrees into minutes and seconds. I'm much more likely just to use decimal values. However, occasionally you'll see a problem in the book that breaks it down into minutes and seconds, and so I just want you to be familiar with that. Okay, now we have a term that describes the position of an angle. So if the angle's initial side lies on the positive x-axis, so here is a coordinate system, here's the x-axis. So the initial side of the angle lies on the positive x-axis, that should say on right there. And also the vertex is at the origin, so you have something like that. That's the initial side. And then the terminal side is somewhere else, most likely. I suppose it could be on the initial side if you had a 0-degree angle or if you had a 360-degree angle. If your angle is positioned in that way, it is called in standard position. So you're going to hear this phrase a lot. Put the angle in standard position. If you hear that, put the vertex at the origin, 0, 0, and put the initial ray on the positive x-axis. Another thing you'll hear a lot is this word, quadrantal. Think of quadrants, like dividing the plane into quadrants. Quadrantal angles are the ones that are multiples of 90 degrees, 90, 180, 270, 0 as well, 360, and so on. So if you were to put a quadrantal angle in standard position, here's the initial side. Every multiple of 90 is going to put the terminal side on an axis. So this would be 90 degrees, for example. So basically, these are the quadrant lines. So we call them quadrantal angles. And then the final term, if you have two angles that have the same initial side, so let's make a sketch. And they have the same terminal side, so maybe like this, but different rotation, they are called coterminal angles. So how could that be? Well, let's imagine that maybe this angle I drew here is, maybe 120 degrees. And let's imagine to get the second one, I went all the way around the circle, 360 degrees, and then I went an additional 120 degrees for a total of 480 degrees. These are coterminal. Different angle measure, same initial side, same terminal side. You could also go counterclockwise. You could go clockwise to get to a coterminal angle. You could go around the circle again and again and again and again. You could go the other way as many times as you wanted. So there are infinitely many angles that are coterminal with any one angle. Next, we're going to do some examples. A lot of them are drawing. Draw an angle in standard position. Okay? So remember earlier we said standard position was on the coordinate system. You put the vertex on the origin. You put the initial side on the positive x-axis, and then you put the terminal side somewhere, wherever. I'm just going to put it here this time. And I'm also going to draw an arrow showing that this angle happens to go counterclockwise. So because of that, if I knew the measure of that angle, it would be positive. Number 2, draw an angle in standard position with a negative degree measure. Okay, so we're going to start out the same way with the vertex at the origin. The positive x-axis is the initial side. And I could even make it look exactly like my previous one, but because it has a negative degree measure, that tells me I'm going clockwise to get to the terminal side. And maybe that one is, I don't know, about 100 and, what would you say, maybe 130 or something. Don't know. Number 3, draw an angle in standard position with its terminal side in quadrant 3. Well, I kind of accidentally already did. So the quadrants are numbered like this. Quadrant 1 is positive, positive. Quadrant 2, Quadrant 3, and Quadrant 4. So who knew that the example I was making up for problems 1 and 2 would also work for problem 3. Initial side, terminal side, that's in Quadrant 3. You can use Roman numerals or just numbers. It's fine either way. Okay, number 4. Draw 3 angles in standard position that are coterminal with a 50-degree angle. Okay, so I'm going to start by drawing my 50-degree angle just approximately, and then 3 more that are coterminal with it. So 50 degrees would be roughly like that, let's say. Okay, so I want 3 angles that have the same initial side and the same terminal side. However, the degree measure has to be different, not 50. So what I could do is go from the initial side all the way around the circle once, that's 360 degrees, and then 50 more. So 360 plus 50 is 410. And then instead of doing that, I could go all the way around the circle clockwise, so that'd be negative 360, and then back 50. So that would be negative 360 plus 50, or another way to think of it would be 50 minus 360, and that would be negative 310. Or instead of just going around the circle 1 time, I could go around the circle 2 times or 3 times, or as many times as I wanted. So if I'm going to go around the circle counterclockwise, let's say twice. All the way around once is 360. Again, now I'm up to 720, and then let's do 50. So 2 times 360 plus 50 is 770. Okay, so you have infinitely many choices. You're either going to add 360 or a multiple of 360 to the number, or you're going to subtract 360 or subtract a multiple of 360 from the number. Number 5, find the complement and the supplement of 28 degrees. Remember, complements add to 90 degrees, supplements add to 180 degrees. So for the complement, we need to take 90 degrees and subtract the given angle, and that will be 62 degrees. And for the supplement, we need to take 180 degrees and subtract the given angle, and that will be 152 degrees. Number 6, convert 20 degrees 30 minutes. Okay, when you see this little symbol here, it means 30 minutes. And over here, when you see this little symbol, it means seconds. So that would be 10 seconds. Remember how we were talking about dividing an angle, dividing a degree into 60 minutes? So if you have 20 degrees and 30 minutes, it means you have 20 degrees and 30 out of 60. 30 minutes out of 60 minutes. So you can just convert that to 1/2. So you have 20 and 1/2 degrees, or if you want, 20.5 degrees. Number 7, we have degrees, minutes, and seconds. So we have our 12 degrees, and then we have 50 minutes, so that would be 50 out of 60 total to make a degree. And then we have 10 seconds, that would be 10 out of 3,600 seconds total to make a degree. So this is going to be 12 plus, I want to get a common denominator. Let me just simplify the second fraction a little bit. Let's get a common denominator of 360. So I'm going to multiply the first fraction by 6. And then I can add these fractions together. I like to keep everything exact as long as I can. So 12 and 301 3/60ths. If I were to put that in the calculator and get a decimal, I don't know, I didn't try it, but it might be something that I would be tempted to round, and if I did that, it wouldn't be exact anymore. Let's see, 301 divided by 360. Yeah, you get like 0.836111111, etc. So if you're trying to keep it exact, leave it as a fraction. Okay, it is time for part 2 of our lesson. We're going to review something that you learned in geometry, your basic trigonometry, sine, cosine, and tangent. I'm going to make this video part 2.